Hello class, and welcome to the final exam study guide review sheet, day 1. Let's go ahead and start with question number 1, which asks, find the distance between the points 3, 4 and 5, 9 on the coordinate plane. And the reason they say on the coordinate plane is just to let you know that these two sets of numbers in parentheses, those numbers are coordinates. And if you take a look right above it, you see that we have the distance formula. We learned in class 3 different methods for finding the distance between 2 points. The first one was to plot the points on a graph, create a right triangle, and use the Pythagorean theorem. In this case, they don't give us a graph, so that's a little bit harder to do. So we've got 2 options, and that is use the distance formula, or go ahead and use what we learned in class as the distance shortcut method. I'm going to go ahead and do both methods. Well, let's do the distance formula first. So I'm going to go ahead and divide this section up here into 2 sections. Let me get a brush here and let's pick a black marker. I'm going to divide this up. Let's do distance formula on the left side of this, and then we'll do the shortcut method on the right side. So we can see the distance formula is right here above, and we should label our coordinates before we start to plug them in. So I'm going to go ahead and label the 3. That's an x value. That's going to be x sub 1. The 4 is a y value in our coordinate plane, so we'll label that y sub 1. Number 5, we'll go ahead and label that as x sub 2. And the 9 we're going to label as y sub 2. And the reason we did this is just to keep you from accidentally plugging in the wrong number into the distance formula. Let's go ahead and write distance is equal to, and the distance formula is a radical or a square root. Let's plug in for our distance formula x sub 2, which is 5, minus, which is part of our equation, x sub 1, which is 3, and that is quantity squared, plus y sub 2, which we've noted as 9, minus y sub 1, which is 4, and that's also quantity squared. Okay, notice the minus sign comes from the equation, so always write that first, and that way if you have a coordinate with a negative number, you'll write the double negative, and that will change it to an adding problem or a positive number. All right, let's continue on. Simplify this. The next step, we're going to go ahead and combine the numbers in parentheses. 5 minus 3 is 2. It's going to be 2 squared, plus 9 minus 4 is 5. That's going to be squared. Let's go ahead and do our squares. 2 squared is 4, plus 5 squared is 25. And we'll go ahead and add those together, and we end up with an answer of the square root of 29. Now that is our exact answer, and that is a correct answer in this case. But many times on a multiple choice or in the instructions for a problem, they'll ask you to round it to a decimal answer. So let's go ahead and do that. Plug square root of 29 in our calculator, and we get, rounded to 2 places, 5.9. So our answer in decimals is approximately 5.39. And since we don't know how far each unit of measure is, we'll just use the generic U for units. So our answer is the square root of 29, or approximately 5.39 units. That's the distance between 3, 4 and 5, 9 on a coordinate plane. In the next video, I'll go ahead and do this same problem, but we'll use the distance shortcut.